graphing with inequalities, okay? So these look almost the same as what you're supposed to graph before. The directions say to graph, okay? You have a quadratic in standard form. The only difference up here between what you've done before is these inequalities rather than an equal sign. Okay, what consequence does that have on the graph for us? So you guys have done this with lines before. You learned how to graph lines, like y equals 3x plus 2. And then you learned how to graph something that would say like y is less than 3x plus 2. What is the difference between those two types of graphs? Okay, Emily.
It's like the dots.
Okay, so first of all, whether you draw the line with a boundary that's like open or closed, so whether it's solid or dashed, okay? And what else? What else is different on my graph visually between graphing y equals 3x plus 2 and y is like less than 3x plus 2? Cody?
I don't want to like properly say it, but like on the other side of the line would be like all those values.
Good, you said it really well. Okay, so on one side of that line that has a boundary, all of those values would be solutions. There's infinitely many solutions. So the way we express the answer is not as like an equation or an expression, but rather like shading on the graph, right? That's visually what you see because we're trying to say all of these infinitely many points, and that's the way that we can express it. So we're going to do that same thing here. It's just that your boundary is changing, and instead of a line, your boundary is going to be what shape? Based on what we're asked to do here. A parabola, okay? And so that might be a little odd to you, but if you think about it, if you have a graph and you graph some sort of parabola, it still divides your graph into two regions. There's like one region that would be this stuff in here, and it goes infinitely upward. It just stays within that boundary of the opening of the parabola. Or there's a region that's all of this stuff that's outside of the parabola, again, which is infinitely large, but would stay outside the parabola. Is that okay with everybody? So same exact idea. It's just that your boundary is now a different shape. It's not a line breaking up the graph, okay? So really this is going to be an exercise in seeing if you understood your inequalities from the past and kind of review graphing quadratics in standard form. Okay, so who remembers the first step to graphing a quadratic in standard form? If I want to get this negative x squared minus 13x minus 36 on the graph, what am I going to have to do? Anthony? Awesome. Okay, so we're going to start off with negative b over 2a, and our b value is that negative 13. So this will end up looking like, it's kind of like this. And so we get 13 over negative 2. And so that's about, let's see, that's negative 6.5. And so I now know where my parabola is centered. I know the axis of symmetry and what my vertex lines up with. How do I find the other coordinate of my vertex? So Anthony remembered the formula for us. He got us started. What do we have to do now, Zoya? Good. I got to plug the x value in to get the y. So I'm going to actually keep it as a fraction. This fraction's a little bit annoying, but I'll deal with it. So 13 squared is 169, and 2 squared is 4. 13 times 13, 169 over 2. 36. And then we have to do some arithmetic, and I'm doing it by hand in case you guys come across fractions. Hopefully yours should be slightly nicer than this, but we need a common denominator, and if you guys see any arithmetic mistakes, let me know. So I want to multiply this by 2 to get this denominator to be a 4, which means I'd also have to multiply this by 2. Just have a seat if you're not sure where. And then I'm going to get 338. Does that look right? Yeah. And then the same thing for this. I need a denominator of 4, so I'm going to multiply 36 by 4. Yeah, 144. Is this okay with everybody? I'm just doing fraction work, okay? So 338 minus 169 is 169. because I got 338 by doubling 169. And 169 minus 144 is 25 over 4. Is this okay with everybody? A lot of fraction work in there, but we figured it out. And so 25 over 4 is equal to 6 1/4. So our vertex is at negative 6.5, and then the y-coordinate is 6 1/4. Okay. So I'm going to find that on here. 1, 2, 3, 6.5, 6 1/4. All right, so there it is. Now I need to get other points on the parabola. How do you get other points on the parabola when your parabola is in standard form and you've figured out where this vertex is with your axis of symmetry? What do we do? Marie? Good. Plug in different x's to get y's. And now normally I like plugging in 0 because 0 is really easy to plug in. Unfortunately, in this case, 0 is very far away from the vertex, 6.5 units over. So when I plug in 0, I'd get negative 36, which is just not convenient for me to graph on this graph. So I want to plug in something that's closer to negative 6.5. But personally, I'd like to plug in a whole number. Okay. So any choices of what you guys want to plug in? 5? Negative 5? Is that okay? Yeah. Okay, so let's try negative 5. So if we plug in negative 5, so we're going for a point where x is negative 5, what are we going to get? So I'm going to have to go through and do this arithmetic. So I'm going to have negative 25 plus 65 minus 36. So that's 40. Okay. Minus 36, which is 4. Okay. So I get the point negative 5, 4. And now I can mirror that point on the other side of the axis of symmetry. So remember, your axis of symmetry is here at negative 6.5. So you have this point at positive 4. It's 1.5 units away from the axis of symmetry. Go 1.5 units on the other side. You have another point, and that's pretty good to give us a picture of our parabola. All right, I drew it in, but I should have thought about it a little more before I drew it in. It's a boundary in this case, right? Because I'm not just graphing the parabola. And what kind of boundary should it be? It doesn't say equal to in our inequality, right? So my boundary should be dashed, meaning like you can, I'm going to have to go back and fix it. Meaning that you want it to divide up the graph. However, solutions are not actually included on this graph. It's the boundary, but you can't use points that are actually on it. Okay? That's why it's dashed. Now I need to know where to shade. And there's kind of two ways for us to figure this out. Who remembers a way that they figure out how to shade when we're doing this with lines? Dylan? Okay, so one way to do it is just to plug in a point and test it. Since we know our graph is being divided into two areas, and one of the areas contains infinitely amount of solutions, and the other area is a place where there are no solutions, we just need to pick something and figure out, is it part of the solutions or not? If it is, that's the part that's shaded. If it's not, we shade the other portion. So if we're testing 0, 0, which is here, okay, we're plugging 0 into this inequality. So 0 for x and 0 for y. So 0 for y and 0 for x. And then this is the statement that would say 0 is less than negative 36. Is that a true statement or a false statement? False, right? So does this point work in this inequality? No. So is this a point a solution of this inequality? No. So that point lies where there are not solutions, which means all the solutions are in the other area of the graph. Remember, the graph has been split into two areas by this boundary parabola. So the solutions are not in that area. They are in this area. Does anybody else have another tactic that they use for shading, just so we can fill people in if there's another way out there? Emily?
I would just see it just as y is less than, so I would do like y less than, so you know.
Good. Good. So she said she's just reading the inequality, and it's literally saying that y is less than the thing that you graphed, that you want to shade the y values that are lower than the points that you graphed along the boundary. So if you were literally sitting at a point along the boundary, the y values below that are here. Sitting at this point, the y values below that are here. Sitting at this point, the y values below that are here. That's pointing to all the areas that I could shade as well. So you can kind of do it intuitively, not my favorite word, but by just understanding the inequality, or by literally plugging in a point. Is that okay with everybody? Okay. All right, any questions on graphing these? Okay, so we want to transition this to be, how do we find solutions to this without necessarily graphing it? Okay, now this had infinitely many solutions, and we're going to find things that do as well, because we were just saying all the points, show me all the points on the graph where y is less than this boundary. That's essentially what this math problem is trying to say to you, okay? What we're going to do is we're going to change the problem a little bit, okay? And we're going to try and say something like 0 is less than this boundary. So you guys don't have to write this part down. I'm just kind of like prepping you for the next idea and how it compares to this. So let's say that I said that, okay? I want to know where 0 is smaller than this, okay? Now the this that I put in the box is the boundary, okay? And where I filled in 0 is like the y value. Are you guys okay with that? So if I'm on the boundary up here, are my y values less than 0 right now if the boundary is up above the x-axis? No. Okay. Then right here where the parabola would hit the x-axis, that would be where the boundary is exactly equal to 0. Those are like the x's that produce a y value of 0. Is that okay with everybody? Then these points down here on the boundary, these would be the points where if you calculated this, you'd get something less than 0, right? However, let's read it again. Do I want the points I'm calculating to be less than 0? No, I want 0 to be less than the points I'm calculating, which means what do I want the answer to be when I plug stuff in here for x? 0 is less than, what kind of number would you have to put there in order for it to make this inequality true? A positive number, okay? In order for this to be true, we'd need a positive number, okay? So actually, we want this stuff up here. Is that okay with everybody? All right? Those are the points that if you plug in x's, you got y's that were bigger than 0. Is that okay with everyone? So what would the answer to what I wrote be? It would be the x's, right? In the problem that I wrote right here, the only thing that's missing is x's. I need you to tell me the x's that I plug into that equation, and they give me positives that are bigger than 0. Does that make sense? So on the graph, it's this part of the graph. Those are the things that are bigger than 0. What are the x's that gave me those things? Can anybody just visually describe to me what are the x's that are the answer to that question that I posed? Where would you find them? So these are all the points that made a y bigger than 0. That's why they're up above the axis. Where are the x's that made those points? Let's say I plot a point right here. What x value makes that point? If that's a true point on the graph. It's a 10-unit graph. 8. That point is made by an x value of 8. Okay? What x value makes all of these points over here? Morgan? Okay, so the x's that are between these values right here. Is that okay with everybody? All right, so we're going to do these kinds of problems in a little bit of a different way. okay, without having to sketch the whole entire graph. So yes, you're responsible for being able to graph the inequality. That's what we did, right? Then the whole conversation I just had with you is more just preparation to do something like that, but not have to draw the whole graph if they just want us to find solutions to this portion if they put a 0 in here, okay, and it's not a y. So if you guys look on the next page of your note guide, if you have the note guide, if you don't have the note guide, you'll just write this part out. We're actually not going to do example 2, that part of the calculator. I need you guys to be proficient in the stuff that we've done in the calculator so far. Okay, so my expectation is you can put in data, you can get regression equations, you can scale the window, you can find minimums, maximums, and zeros. That's what I'm looking for you guys to be able to do. Okay, all right, so we're going to analyze things like this. So notice right here is like the same problem you had. The only difference is it's already in factored form. Okay, and they want to know, when is this quadratic, this parabola, less than 0, okay? Which means, what did we talk about? What would you actually want the outcome to be here if you want it to be less than 0? What kind of number? A positive number? A negative number. So really the question you're trying to answer is, what x's does someone plug into the stuff on the left side that will for sure produce a negative, because that would be less than 0. Is that okay with everybody? So by answering this question, I want to tell them all the x's I can plug in there that give me a negative, all right? Now, if you look back at how our parabola works, what we want is, we really want to know where the parabola hits the x-axis, because that kind of divided it to the part of the parabola that was above 0 versus the part of the parabola that was below 0. Is that okay with everybody? Those solutions right on the x-axis were kind of key in figuring that out. Now, when we graphed this parabola, we did not figure out those exact solutions. We were drawing a sketch. However, look how nice, it's kind of nice they gave it to us in factored form, now that we think about it that way. They gave us this one in factored form, so I'm not going to sketch the whole graph, but I do want to know first, what are the solutions? Like, what are the places that this quadratic would cross the x-axis if I were graphing it? And again, the reason I want to know that is because I'm trying to compare it to 0, so I want to identify the points where it's exactly equal to 0, because I know that's breaking it up into the places where it might be above 0 versus it might be below 0. Okay, Emily? Good, it's 4 and -7. Do you guys see where she's getting those? They already nicely factored it for you, so it's actually very quick to solve. We can just set each of the factors equal to 0, and we get x equals 4, x equals -7. Now, here's where people make the error. They then just take the inequality and they give me an answer like x is less than -4, or 4, -7. Or they say x is less than 4, x is greater than -7, without ever thinking about anything else. But that doesn't make sense. Why would we even learn this if that was the case, right? We've done nothing more than what we've done before, okay, at this point. So we need to do an analysis like we just talked about on the last graph. We need to understand which x's made the parabola go above the x-axis and which x's made it go below, so we understand which x's are actually making a negative when you plug them in. Is that okay with everybody? So the way we're going to do that, you can draw the whole graph and you can do what we just did. Or you can draw a mini version of that. And the mini version of that would look like this. Here is just my x-axis, okay? The reason I care about my x-axis is because if the graph goes above the x-axis, then those are the positive values of y, right? And if it goes below the x-axis, those are the negative values of y. I'm comparing it to 0, which means I really just want to see the split between the negatives and the positives, okay? Now, I know exactly where it hits 0 on the x-axis. You guys just found those solutions right here. It will cross the x-axis at -7 and also at +4. Okay? And the way I draw these points in is going to depend on what you look at right here. If you were drawing the graph of this boundary, it says less than, not less than or equal to. Would we draw open points or filled in points? Open, because it's a boundary, but it's not technically part of the answer. So that's the way I'm going to draw my zeros on here. Like, hey, it does cross the x-axis, but it's not actually part of the answer. It's just like a dashed little boundary going around, which means these points would be thought of as like open points. Okay? And then I want to know, okay, these split up the little sections which section of the parabola is going above the x-axis and which section is going below, okay? So if you really want to know, you could sketch it, but the other thing you could do is you could just plug in some numbers. Try plugging in a number from this area. And this area on the x number line means numbers that are smaller than -7. Those are the x's that would be in that part of the number line, right? If you pick a number smaller than -7, and I'm going to do it a little bit differently than you guys are used to because this is going to help us later on in our class. I'm not actually going to do all the arithmetic. I really just need to know, do I get a positive answer or a negative answer, right? That's all I need to know. So I have some number that's x minus 4 and something else that's supposed to be x plus 7. If I plug in a number smaller than -7, everybody think of your own number in your head. Don't tell anyone else. Pick a number smaller than -7. Okay, when you do that number minus 4, do you get a negative or a positive? The number in your head minus 4. Negative. When you do that number in your head plus 7, do you get a negative or a positive? Negative. Would anybody get anything different if they're using a number that's smaller than -7? No. So do you see how I don't really care about the number? I'm just saying any number, and I don't care the exact value it works out. I just need to know the sign. And a negative times a negative would end up making a positive. So overall, when you plug in these x's, you're going to get positive y values. Is that okay with everybody? That's all I'm saying here without drawing the graph. So I can either see it by drawing the graph. Oh, these x's makes points up here. They're giving me positive y values. Or I can just plug in a number real quick to see. Okay? All right, what if you plug in something between -7 and 4? Like 0 would be nice, right? I would get a negative and then a positive, and a negative times a positive would make a negative. So every x that you plug in between -7 and +4 is going to make a negative outcome in this side of this expression. Okay? Then if you pick a number that's bigger than +4, you would get a positive and a positive, and multiplied together, those make a positive. Okay? Now that we've wrapped our head around what's happening, we know where this equals 0, where it's making things that are bigger than 0, and where it's making things that are smaller than 0. Go back and figure out, what are you supposed to answer to this question? What makes this inequality true? You want the left side of this inequality to be what? What did we say at the beginning? Negative. Because if it's supposed to be less than 0, it's supposed to be negative. That means our answer is the area where it was negative. So these x's made a negative value when I plugged them in. Those are my solution. Is that okay with everybody? And now I need to write that in a correct way. And this I can write. I don't have to leave the graph because it's not a two-dimensional graph where it's like x's and y's. It's just x's that we're talking about. So what x's made the solution? X's that are less than 4, but at the same time, greater than -7. Is this all right with everybody? Okay, so you're telling me the x's that when plugged into this quadratic make something that's negative, or they make something that's positive. Okay? Yeah, Morgan.
If it wasn't between, would it just be like x is greater than 4?
Or x's. Yeah, we'll see one that's not between in a little bit. Okay? Is this all right with everybody? Do you see how this is like the entire problem right here? So if you're not like sketching the graph and thinking about what's happening, I don't know how you're just randomly taking these numbers and making the answer. Does that make sense to everybody? Yeah, you can start generalizing patterns like, oh, when it's negative, it's in between. Well, not if I put a negative at the front of here and flip it around, then it's going to be totally different. So unless you're going to generalize about 6 to 8 different patterns for yourself about how you should write the answer, you need to do this little analysis, okay? All right, so we're going to do part B. Part B, we want to do the same thing. But notice, we don't want to compare it to 5. Comparing things to 5 would be a lot more difficult because we'd have to figure out when the quadratic exactly equals 5. It's a lot easier to figure out when the quadratic is equal to 0 and separate those intervals. So we want to bring the 5 to the other side. And then you're working on your solving skills. Now, technically, you can solve using quadratic formula, completing the square, or factoring. Factoring is going to be my first choice, especially with nice little numbers like this, okay? And if we factor this, this actually factors as p minus 5 times p plus 1. And our p is like our x. So what does that mean the solutions would be if this was an equation and not an inequality? Our answers would be what? P equals 5 and negative 1. What are those for us in an inequality problem? They're not necessarily solutions. Maybe they're part of it. But what are they going to do for us? What are we going to do with 5 and negative 1? Good. We're going to point out those points on the x-axis because they are dividing up our axis into the places where it would cross, meaning those are the places where it's changing from positive to negative or negative to positive. Now, how should I draw the points in this inequality? Open or filled in at those points? Filled in. These are actually part of the answer. My answer will include negative 1 and 5 because those make this equal to 0, and the inequality says we can be equal to 0. Okay? And then I quickly go through and I do the analysis on the 3 sections. What's happening with these different sets of x's where it's crossing the axis? So if I pick numbers smaller than negative 1, I would end up with a negative times a negative, which would end up being positive. If I pick a number between negative 1 and 5, say like 0, I end up with a negative times a positive, which makes a negative. And if I pick things bigger than 5, then I get something like a positive times a positive, which is a positive. It doesn't work out this way every time. It depends on whether your a value is negative or positive and stuff like that. But it is a parabola, so if it is crossing the axis twice, you are seeing like positive, negative, positive, or negative, positive, negative, because it's crossing back over into the other side of the graph. So which part actually answers this question? We want this calculation to turn out to be what kind of number to make this inequality true? Negative, right? If you guys are struggling with that part, you should ask yourself, what do I want? What kind of number would be less than or equal to 0? What would make this true? And a negative would make it true, which is this part here. And then we would say that P is between 5 and negative 1. Right? Okay, and then let's do one more and look at part C. So again, bring the 4 over. Okay, you can't compare it to 4. You need to compare it to 0. And then we want to try and factor it. First would be, I mean, you can use quadratic formula, but then the numbers aren't going to be as nice. And so factoring would be kind of my first go-to every time. So I don't know. Let's see. I'm going to try a couple things. You guys factor on your own. 6 and 4 is going to be too much. 8 and 3 will be good. Okay. There we go. So 3s plus 4 and 2s minus 1. So my solutions here would be fractions. That's okay. Doesn't matter. It can cross the x-axis at rational, irrational numbers, fractions. Open or closed solution points here? Open, right? This is where it equals 0, but I'm not allowed to be exactly equal to 0. I only want my equation to produce things greater than 0 to make this inequality true. Okay? Then you plug in numbers again. So pick something like negative 10, something that's really negative so that you know it's in this area here. Okay? And negative 10 would give you a negative times a negative, which is positive. Something like 0 in the middle would give you a positive times a negative. Something really big will just give you big positive numbers. Yeah. So it works out like this. And so then look, you want whatever's on this side to be greater than 0, which means you're looking for the outcome to be positive values. The outcomes were positive here, which were produced by these and these values. Okay? And then because these inequalities are not a single thing that's trapped between 2, you do have to write 2. So this is what Morgan was asking earlier. So we would say that S is less than negative 4/3, or S is greater than 1/2. So when I'm writing this solution, I'm just naming the part of the number line that I identified to give me the answers. Okay? But do you understand what I said at the beginning, where the people who aren't sketching the graph, I don't know what they're doing when they're doing inequalities. And I can't really give you, you know how we're pretty good about giving you guys like partial credit and stuff like this as far as the grading goes. If you do this problem like it's not an inequality, I don't feel like I can give you any partial credit. That's literally the only thing that makes it different from solving the equations that you were doing before. Does that make sense to everybody? Like that's the one distinctive characteristic about this, is doing the analysis. So don't forget to do the analysis, okay? We'll look at one more because it's a little bit unique. If we look at this last one, the try these, and you guys can try some more of the try these. I'm gonna bring the 16 over. So this kind of points out a unique situation, because if you factor this, you actually get a perfect square, which means at how many places is this quadratic equal to 0? Only one. So we don't have the number line split how we normally do. It's only going to be equal to 0 at one spot, and that would be at -4. And I'm going to fill that in because it can be equal to 0. But I still do the same thing. I still test on each side. If I plug in a number smaller than -4, it makes something, but then it squares it, so it ends up being positive. If I plug in something bigger than -4, it makes something, but then squares it, and it ends up being positive. And what kind of outcomes am I looking for to make this inequality true? I want the outcomes over here to be greater than 0, which is positive, which is all of this and all of this, and the -4. So my answer here would be all real numbers. Okay. How could you have changed this so that your only answer was -4? How could you have changed the problem? How could I have written the problem differently so that the only answer would have been -4? Stefan?
Maybe like flipping the sign at the beginning.
Right, so he's saying flipping the sign at the beginning. So you have your inequality, but I say that you want it to be less than or equal to 0. Does everybody see how that would always work out in -4? Because you would have positives, so you would never be below, but you would just have -4, right? How could I make this so that it has no solution? I see Morgan's hand. She's checked this out a bunch. Somebody new. How could I make it so there's no solution? Sydney? Yeah. Flip it and remove the equal part. So what if I said it had to be less than 0, not less than or equal to? Then -4 would have been open, just a dividing point, but nothing else. Okay? Is that all right with everybody? Okay, and what if there are no solutions to the quadratic? Could there still be solutions to the inequality? Yeah, because you would have nothing hitting the number line, right? But that means your whole thing either exists in the positive or the whole thing exists in the negative, and it would just depend on what the inequality is asking for. If it says when is it positive and the whole thing was in the positive, then the answer would be everything. If it asks when is it less than 0, like in the negative, but the whole thing is positive, then the answer would be no solution, never. Is that okay with everybody? But do you see how the analysis is really important? If you don't know what's going on and what the problem's asking for, you really can't answer this inequality question. Okay? All right, so that is basically